In this series of videos, I'm going to take a more careful look at graphing with trig functions. And I really think the key to being able to graph trig functions well is understanding what the sine and cosine function look like and really having a good handle on that. And if you have a good handle on those features, everything will come from there. So the sine function crosses the axis at 0 degrees, 180 degrees, or pi radians, and I'm going to use pi radians, and 360 degrees, or 2 pi radians. I'm also going to try to do a little bit more with radians in this video to get us a little bit more comfortable thinking in terms of radians. All right, so I usually start out with the intersection points of the graph on the midline. It's going to be done different ways, but that's always worked pretty well for me. So this is going to cross at 0, it's going to cross at pi, and it's going to cross at 2 pi. Okay, and the amplitude of the sine function is 1. The sine function goes up first, and then it goes down on the second half of the graph. So you can really just go halfway in between the two intersection points on the axis, and you can go up the amplitude level. It's going to max out at that point right there. You can go halfway between these points. You can go down a unit, and notice here, by the way, I'm using these as half units, so that's 1 unit tall up to here, that's 1 unit down there. And then you can draw your curve through. That works out pretty nicely. Do show ends on your curve, show your curve continuing. You may want to have it go back at least 1 cycle back through negative pi and kind of continue like that. When I see a graph, make sure that I can see clearly plotted points where it intersects the axis with some kind of a labeling, and also the high points and low points, okay? Now, by the way, really, this crosses at 1 pi. This is half of that. That would be pi over 2 or 90 degrees. Wouldn't be terrible to label that. This is halfway between 1 and 2. That's 1.5 pi. We usually write that as 3/2 pi or 3 pi over 2. So that's what the sine function looks like. All right. Let's take a look at the cosine function. The cosine function is essentially a shifted version of the sine function. It is shifted back, technically pi over 2 radians. So the cosine function is going to cross the axis at negative pi over 2, or negative 1/2 pi, or negative 90 degrees, pi over 2, or 90 degrees, and then 3 pi over 2 radians. So on this graph here, I'm going to add that in. Negative pi over 2 is going to be right here. Pi over 2 is going to be right here. 3 pi over 2 is going to be right here. And again, I usually start out with those intersection points. So it's going to intersect here, it's going to intersect here, it's going to intersect here, okay? And the amplitude is going to be 1. Goes up first, okay? And by the way, a really key feature of the cosine function, for a value of x equals 0 starts out at its maximum point. You can see here the sine function for x equals 0, sine is also 0. It starts out at the origin. When we start modeling functions using sine and cosine functions and trying to decide which equation to use, that's going to be a really important feature for us. And the cosine function is going to reach a minimum value at pi radians. So then we can draw in the curve here. And again, it continues, so hits a maximum value again at 2 pi, and it wouldn't be a terrible point to have on your graph as well. And it's going to hit a minimum point at negative pi, and it's going to continue this way. And so that's what the sine function and cosine functions look like. And again, just really shifted versions of each other. All right, moving on to other graphs. So we have a couple of basic transformations. Hopefully at this point we're pretty comfortable at identifying amplitude, the equation of the midline, and the phase shift and period. So if you notice here, the amplitude of this function is going to be 3. So we're going to go up 3 and we're going to go down 3. And you know what, I just realized my graph. Let me do 2 sine of 2x. I don't have enough room on my graph to do 3 sine of 2x. We'll do 2 sine of 2x plus 1. and that's going to make the amplitude 2. Okay, it's going to be shifted up 1 unit, so the midline is going to be at y equals positive 1, or you could think of it as being shifted up 1 unit. The phase shift, it's not, there is no phase shift. You could say it's 0 degrees or 0 radians. It's not shifted left or right. There's nothing being added or subtracted to this x. And then finally the period. Remember, this value here is not the period. It's the multiplier, okay? One way you can think about it is the graph is going to move 2 times as quickly. It'll go through 2 cycles between 0 and 2 pi radians, for example, instead of 1 cycle. What that really does is it means the period is going to be divided by this multiplier. If it moves twice as quickly, that means the period is going to be half as big. So you can take either 360 degrees and divide by 2, and the period is going to be 180 degrees. Or my preference in graphing, what we're going to use more often is radians. 2 pi radians divided by 2. The period is going to end up being pi radians. All right, and now we should be able to put all that information together in a graph. So the first thing I start out with is the midline, because I always plot the intersection points along the midline. This equation here, 2 sine of 2x plus 1, is going to have a midline at 1. And so I kind of dot this in. This isn't actually part of the graph, so technically doesn't have to be shown, but I have a tendency to start plotting in the wrong place if I don't draw in my midline. So draw in your midline, and then you can look at your intersection points, okay? Now this is a sine function. The normal sine function is going to intersect the axis at 0, pi, and 2 pi, or 0, 180 degrees, and 360 degrees, okay? This one has a period that's half as big. I will always write down the intersection points along the axis for the base version of the graph, okay? And since the period's going to be half as big, we're basically dilating this in by a factor. We're smashing it inwards, horizontally compressing it, if you want to call it that. So each of these is going to be divided by 2, and that means it's going to cross the axis at 0, pi over 2, and pi. Okay, and that's where I try to put my intersection points. Okay, 0, pi over 2, and pi. So it's going to cross at 0. I'm going to plot that point right there. It's going to cross at pi over 2, which is right here. Okay, and then it's going to cross at pi. And again, you may want, it would really be a good idea to label that pi over 2 there on your graph. Okay, now the next thing, there's no phase shift. We don't have to worry about that. If there was a phase shift, we would have to take those 3 points and we'd have to shift them left or right next. But you always want to get the period set up first so the graph has the right period, and then you can just move everything left or right. The last thing we need to take care of here is the amplitude. Okay, the amplitude is 2. So remember, the sine function goes up first. So you're going to go up 2 from this first point. That's actually going to take us up to 3. Yeah, which is going to go a little bit off my graph. That's 1, 2 units up. So we'll plot a point right there, and again, I'm going up in the other graph. That's supposed to be 3 on my graph, right? It's going from 1 up to 3. I just didn't leave enough space. And we're going to go down 2 in between these 2 points. Remember, I'm counting, this is only 1 unit, so it'll go down to -1. And so my graph is going to look something like this. And it's going to kind of continue like that. Okay, now it would be good, I'd really like you to have the other points here as well. Notice this is halfway between 0 and pi over 2. It's half of 1/2. Half of pi over 2 is pi over 4, or 1/4 pi. By the way, you can count by fourths. This is 1/4 pi, 2/4 pi, 3/4 pi would be this point right here, right? 3 pi over 4. 4/4 pi would be 1. 5/4 pi. 6/4 pi would be 2 pi over 3 pi over 2. And then you can kind of continue like that. And again, you don't have to label all of those points. But that's the basic idea. So that's the graph of y equals 2 sine of 2x plus 1.